Welcome to Science by PK. Today we're diving into the incredible world beneath our feet, Earth science. Our planet is full of unique landforms like mountains, volcanoes, plateaus, and plains. But what exactly are these features? How do they form? How do they affect our lives? Stick around because by the end of this video, you'll see Earth's surface in a whole new way. Let's start with mountains. Mountains are some of the most dramatic landforms on Earth, rising high above the surrounding land. They usually form when huge plates of Earth's crust collide and push upward, like two cars crash and crumple. The Himalayas, home to Mount Everest, are still growing because the Indian and Eurasian plates continue to push against each other. Mountains affect our climate by blocking winds, creating rain on one side and dry conditions on the other. They also provide fresh water, since snow that melts from mountain peaks feeds rivers that millions of people rely on. Now let's talk about volcanoes, which are not just mountains. They are openings in the Earth's crust where molten rock called magma escapes from deep inside the planet. When this magma erupts onto the surface, it becomes lava. Volcanoes form mainly along plate boundaries over hotspots where heat rises from Earth's mantle. Volcanoes can build new land like the Hawaiian Islands, but they can also be destructive. Explosive eruptions release ash, gas, and lava flows that can destroy homes and change the climate. For example, the eruption in Mount Tambora in 1815 caused a year without summer, lowering global temperatures and affecting crops worldwide. Next up is plateaus. A plateau is a large flat land that is raised higher than the land around it. Imagine a giant table made of rock with a flat surface on the top. Plateaus can form from volcanic activity where the lava spreads out and cools, or from uplift when forces inside Earth push up land without folding it. Plateaus influence weather patterns, provide rich glazing lands, and often contain valuable minerals. The Colorado Plateau in the United States is famous for its layered rocks and deep canyons carved by rivers, including the Grand Canyon. Moving on to plains. Plains are broad, flat areas of land with gentle slopes. They often form from deposited sediments left behind by rivers, wind, or ancient seas. Plains are extremely important to humans because they have fertile soil, making them ideal for farming. Many of the world's major cities and agriculture regions sit on plains, such as the Great Plains in North America and the Indo-Gangetic Plains in Asia. There are many other natural features as well, such as valleys created by rivers cutting through land and deserts shaped by wind erosion and dry climates. Each landform tells us a story about Earth's powerful forces: erosion, weathering, tectonics, and volcanism. Mountains. These towering giants shape our planet, control our weather, hold life-giving water, and tell us a story of Earth's powerful forces. So what exactly are mountains? How do they form? And where can we find the tallest and largest ones on Earth? Let's explore. A mountain is a landform that rises sharply above the surrounding land, usually with steep sides and a noticeable peak. Mountains don't just appear overnight. Most of them take millions of years to grow. The main driving forces behind mountain formation is the tectonic activity, where massive plates of Earth's crust move, collide, or slide past each other. When the two plates push together, the land can crumple and fold upward, forming mountain ranges. This process is called orogeny, also known as mountain building. Now let's talk about mountain ranges. A mountain range is a connected series of mountains formed by the same geological process. Think of it as a long chain of peaks that share a common origin. Famous examples include the Himalayas, the Andes, and the Rockies, and the Alps. When many mountain ranges are linked together in a huge region, we call it a mountain belt. Mountain belts can stretch across entire continents and represent some of the most dramatic features on Earth. So what is the largest mountain range in the world? Surprisingly, it's not on land. The world's biggest mountain range is the Mid-Atlantic Ridge, an underwater chain that runs down the center of the Atlantic Ocean. It's over 400 100,000 miles long and formed by tectonic plates pulling apart, allowing magma to form below to rise and create new crust. Even though it's underwater, it includes volcanoes and peaks that rival those on land. But what about the largest mountain range on land? That title goes to the Andes mountain range in South America, stretching around 4,300 miles along the western coast. And the Andes are home to high peaks, active volcanoes, glaciers, and unique ecosystems. Now let's climb even higher and talk about the tallest mountains in the world. The tallest mountain above sea level is Mount Everest, standing about 8,849 meters, around 29,000 feet. Everest is part of the Himalayas, a massive mountain range formed by the collision between the Indian and Eurasian plates. Believe it or not, the Himalayas are still growing today as the plates continue to push against each other. However, if we measure from the base to peak, the tallest mountain is actually Mauna Kea in Hawaii. Most of it is underwater, but from its ocean floor base to the summit, it reaches over 10,000 meters, making it taller than Mount Everest in total height. Mountains are more than just tall rocks. They affect our climate by blocking winds and controlling rainfall. They store fresh water in glaciers and snowpacks. They provide habitable habitats for unique plants and animals. Millions of people depend on mountain water for drinking, farming, and energy. Mountains shape our world physically and culturally, inspiring exploration, adventure, and scientific discovery. Plains. They may seem simple and flat, but plains have shaped human history, ecosystems, weather, and life on our planet in ways most people don't even realize. So, what exactly are plains? How do they form, and why are they so important to us? Let's break it down. Plains are large, broad, flat regions of land with little change in elevation, unlike mountains or plateaus. Plains stretch wide and smooth across the Earth's surface. But don't let their simplicity fool you. Plains are the result of powerful natural processes that take thousands or even millions of years to form. So how do plains form? One major way is through deposition. Rivers carry sediments like sand, silt, and clay from mountains and deposit them over time, slowly building up wide, fertile plains. These are called alluvial plains, and they are some of the most productive landscapes on Earth. Another way plains form is through the retreat of ancient seas. When oceans move, they leave behind flat seabeds filled with sediments, which later become coastal plains. Wind can also shape plains by blowing and smoothing out loose material, creating erosional plains, where hills and rough terrain are worn down over millions of years. Plains also affect weather. Their wide open shape allows the winds to travel long distances without obstruction. This creates unique climates, like the strong winds of the Great Plains in the United States or the monsoon-influenced plains of India and Bangladesh. Plains can even influence storm formation because of the temperature differences between the land and the atmosphere above it. But the most important impact of plains is on human life. Throughout history, humans have relied on plains for survival. Why? Because plains often have rich, fertile soil, which makes them perfect for farming crops like wheat, rice, corn, and barley, which thrive on plains. This is why major civilizations from the Nile Valley to the Indus Valley to the Great Plains grew on these regions. Plains are also easier to build on, making them ideal for cities, transportation, and trade routes. Plains also support countless animal ecosystems. Grasslands and savannas are home to grazing animals like bison, antelope, and wild horses. Even though these areas look flat and simple, they host some of the most productive food chains on Earth. So why are plains so important today? Because they continue to the backbone of human civilization. Our food, our cities, our transportation networks, and even major economic systems depend on these wide open landscapes. Plains may not rise high like mountains or erupt like volcanoes, but they are one of the most powerful and life-supporting landforms. Volcanoes. We'll explore how volcanoes form, the different types of volcanoes, and some of the most powerful volcanoes ever known. So first, what is a volcano and how does it form? A volcano forms when molten rock called magma rises from deep inside a planet's mantle. Heat and pressure build up beneath the Earth's surface, and when magma finds a crack in the crust, it erupts as lava, ash, and gases. Over time, repeated eruptions build volcanic mountains and landforms. Now let's look at the main types of volcanoes. The first type is the shield volcano. Shield volcanoes are wide, gentle, sloping volcanoes formed by very fluid lava that spreads out over long distances. A famous example on Earth is Mauna Loa in Hawaii, the largest active volcano on Earth by volume and area. Even Olympus Mons on Mars, the largest volcano in the solar system, is also a shield volcano. Next are stratovolcanoes, also known as composite volcanoes. These volcanoes are tall, steep, and built from layers of lava and ash. They often produce powerful eruptions. Famous examples include Mount Fuji in Japan and Mount Vesuvius in Italy. Stratovolcanoes are some of the most dangerous volcanoes because of their explosive potential. Another type of volcano is the cylinder cone volcano. These are smaller volcanoes formed from lava fragments that fall around a single event. They usually erupt only once or a few times. An example is Partican in Mexico, which famously formed in a farmer's field in 1943. Volcanoes can also be classified by activity. Active volcanoes are currently erupting or likely to erupt again. Dormant volcanoes are quiet now but may erupt in the future, like Mount Fuji. Extinct volcanoes are not expected to erupt again. So what is the most powerful volcano today? There isn't one single strongest volcano, but supervolcanoes are the most extreme. Yellowstone in the United States is one of the most famous supervolcanoes. If a supervolcano like Yellowstone erupted fully, it would have global effects, including climate changes. The largest eruption ever known on Earth happened at Lake Toba in Indonesia about 74,000 years ago. It was so powerful that it may have affected human populations worldwide. And beyond Earth, Olympus Mons remains unmatched, both the largest and one of the most powerful volcanoes ever discovered. Northern Lights. What are they? How do they form? Why do they glow in different colors? And where can you see them? We'll all break it down in this episode, so stick around until the end. And before we get started, make sure to like this video, subscribe to Science with PK, and hit the notification bell so you never miss out in any of our science explorations. Let's start with the basics. What are Northern Lights? Also known as Aurora Borealis. They're colorful lights that dance across the sky, usually in places near the North Pole, but they are not just pretty. There's incredible science behind them. How do northern lights form? It all starts with the sun. The sun is constantly sending out streams of charged particles in something called solar wind. These particles race across space at incredible speeds, sometimes even over 1,000,000 miles per hour. When they reach Earth, they collide with our planet's magnetic field, which acts like a protective bubble, keeping most of these solar winds from reaching the surface. However, at the North and South poles, Earth's magnetic field is weaker, allowing some of these charged particles enter the atmosphere. When they do, they crash into oxygen and nitrogen molecules in the air, exciting them and causing them to glow like neon lights. This is what creates the northern lights and the Arctic and southern lights near Antarctica. Why do northern lights have different colors? The colors of the auroras depend on which gases the charged particles collide with and how high up they are in the atmosphere. Green is the most common color because it comes from oxygen molecules at lower altitudes. Red auroras are much rarer, and they happen when oxygen is hit at higher altitudes. Blue and purple auroras appear when the particle collides with nitrogen instead of oxygen. This is why no two aurora displays are ever the same. They depend on the type of solar activity happens, the altitude of the particles, and the composition of the atmosphere. Where can you see northern lights? The best places to see the northern lights are in a region called the Aurora Oval, a ring-shaped zone around the North Pole. Countries like Norway, Sweden, Finland, Iceland, Canada, and Alaska are among these best spots to witness this dazzling display. But sometimes, when solar activity is strong, auroras can be seen as far south as the United States and parts of Europe. If you want to see the southern lights or the northern lights, your best bet is Antarctica, New Zealand, or the southern parts of Australia. Why we
don't see northern lights every night, the northern lights aren't always visible because they depend on solar activity. The sun goes through a 11-year cycle when solar storms increase and decrease in intensity. During times of high solar activity, more charged particles reach Earth, leading to brighter and more frequent auroras. Scientists track this using something called the KP index, which measures geomagnetic activity. The higher the KP value, the more likely you are to see the auroras. Do other planets have auroras? Yes, northern lights aren't just in Earth. Other planets in our solar system like Jupiter, Saturn, Uranus, and Neptune also have auroras. Since their atmospheres are made up of different gases, their auroras glow in different colors and patterns. NASA has even captured stunning auroras on Jupiter using the Hubble Space Telescope. Final thoughts: the northern lights are more than just a pretty sight. They are a cosmic light that shows light show powered by the sun. They help scientists understand how Earth interacts with space and weather, and they remind us of how incredible forces are shaping our planet.
Canyons. These massive natural trenches cut deep into the landscape and tell a story that took millions of years to write. We'll explain what canyons are, how they form, and explore some of the most famous and largest canyons in the world. So first, what is a canyon? A canyon is a deep, narrow valley with steep slides, often carved into rock. Most canyons are formed by rivers slowly cutting through the land over long periods of time. Compared to regular valleys, canyons are usually deeper, steeper, and more dramatic. Now let's talk about how canyons form. The main force behind canyon formation is erosion. When a river flows across land, it carries water, sand, and rocks. Over millions of years, this moving water slowly wears away the rock beneath it. As tectonic forces lift the land upward and the river keeps cutting downward, a canyon begins to form. Wind, rain, ice, and gravity also helps shape and widen the canyons over time. These are different types of canyons. River canyons are the most common and carved by flowing water. Slot canyons are very narrow when water rushes through cracks in rock, often found in desert regions. Submarine canyons exist underwater and are carved into the ocean floor by underwater currents and landslides. The most famous canyon in the world is the Grand Canyon, located in Arizona, USA. The Grand Canyon is about 277 miles long, up to 18 miles wide, and more than a mile deep in some places. It was carved primarily by the Colorado River over the last 5 to 6 million years. The rock layers inside the canyon reveal nearly 2 billion years from Earth's history, making it incredibly important to scientists. So, what is the largest canyon in the world? On Earth, one of the largest and deepest canyons is the Yarling Tensukopo Grand Canyon in Tibet. Some areas it's deeper than the Grand Canyon and stretches for hundreds of miles through the Himalayas. But the largest canyon we know is actually not on Earth. The Valles Marineris on Mars is actually the largest canyon in the entire solar system. It is over 2,500 miles long and up to 120 miles wide and several miles deep. Scientists believe it formed due to massive cracks in the Martian crust, followed by erosion and collapse. Canyons are important because they help scientists understand Earth's geological history, climate changes, and erosion processes. They also shape ecosystems and provide habitats for plants and animals. From the Grand Canyon on Earth to the giant canyons on Mars, these landforms show how powerful natural forces can be given enough time. Grasslands. Grasslands may look simple at first, but they play a huge role in supporting life on our planet. Let's find out what grasslands are, how they form, and why they are so special. So first, what are grasslands? Grasslands are large areas of land where grasses are the main type of plant. Trees are rare, and the land is mostly open and flat for gentle rolling. Grasslands exist on every continent except Antarctica, and cover about 1/4 of the Earth's land surface. Now let's talk about how grasslands grasslands form? Grasslands usually develop in places where there's not enough rainfall for forests, but too much rain for deserts. Seasonal rain helps grasses grow, but long dry periods prevent trees from taking over. Natural fires and grazing animals also help maintain grasslands by stopping shrubs and trees from spreading. There are two main types of grasslands: temperate grasslands that are found in places like North America, Europe, and parts of Asia. These include the Great Plains of the United States and one of the most famous grasslands in the world. Tropical grasslands are the next one, also called savannas. They are found in warmer regions near the equator, such as Africa. The Africa savanna is one of the most well-known grasslands on Earth. So what makes grasslands special? Grasslands have incredibly rich soil, making them perfect for farming. Many of the world's crops are grown on former grasslands. Their deep grass roots help prevent erosion and store carbon, which helps regulate Earth's climate. Grasslands are also home to many animals, large herbivores like bison, zebras, antelope, and elephants that graze on grasses. Predators such as lions, cheetahs, wolves, and foxes hunt in open grasslands. Smaller animals like prairie dogs, prairie snakes, rabbits, insects, and birds also thrive there. Many animals are adapted to run fast or burrow underground to survive. So what can be considered a grassland? Any large open area where grasses dominate and trees are limited can be classified as a grassland. This includes prairies, plains, palmas, steppes, and savannas. Grasslands are typically located between forests and deserts, acting as a transition zone between different ecosystems. Even though they may not look dramatic, grasslands are some of the most productive and important ecosystems on Earth. Oceans. Oceans cover most of the Earth's surface, help regulate our climate, and support an incredible variety of life. Let's explore what oceans are, how many there are, and what lies beneath the surface. So first, what is an ocean? An ocean is a massive body of salt water that covers large areas of Earth's surface. Oceans are deeper and much larger than seas, and they are connected to each other, forming one global ocean system. Together, oceans cover about 71% of Earth's surface and contain most of the planet's water. There are 5 oceans in the world. The Pacific Ocean, the largest and deepest ocean known on Earth. The Atlantic Ocean is the second largest and is known for its strong currents. The Indian Ocean is the warmest ocean and lies mostly in the southern hemisphere. The Southern Ocean surrounds Antarctica and plays a major role in global climate. The Arctic Ocean is the smallest and shallowest ocean located near the North Pole. So what can be considered an ocean? To be classified as an ocean, a body of water must be extremely large, salty, and deep, and it must be connected to the global ocean system. Smaller bodies of water, like the Mediterranean Sea, are considered seas, not oceans. Now let's explore the layers of the oceans, also called ocean zones. The top layer is the sunlight zone, also known as the deep hypolic zone. This layer extends down to about 200 meters. Sunlight reaches this zone, allowing plants like phytoplankton to grow. Most marine life, including fish, whales, dolphins, live here. Below that is the twilight zone. Very little sunlight reaches this layer, making it dim and shadowy. Animals here often have large eyes or produce their own light through bioluminescence. Next is the midlight zone. This zone is completely dark and extremely cold, with very high pressure. Strange creatures like giant squids and deep-sea fish live here. Below that is the abyssal zone, where temperatures are near freezing and food is scarce. The deepest layer is the hadal zone, found deep ocean trenches like the Mariana Trench. This is one of the least explored places on Earth. Oceans are incredibly important because they help control weather and climate, produce much of the oxygen we breathe, and provide food and resources for billions of people. They also remain one of the most important, mysterious parts of our planet. Glaciers. These massive bodies of ice may move slowly, but they have shaped landscapes, stored fresh water, and played a huge role in Earth's climate for thousands of years. Let's break down what glaciers are, how they form, and why they matter. So first, what is a glacier? A glacier is a large, thick mass of ice that forms on land and slowly moves due to the gravity. Unlike regular ice or snow, glaciers are made up from layers of snow that have built up and compressed over long periods of time. Because of their size and weight, glaciers flow like very slow rivers of ice. Next, how do glaciers form? Glaciers form in places where more snow falls in winter than melts during the summer. Over many years, snowfall piles up. The weight of the snow on top compresses the layers underneath, turning the fluffy snow into dense ice. Once the ice becomes thick enough, gravity causes it to slowly move downhill or outward. There are two main types of glaciers. Alpine glaciers, also called valley glaciers, form in mountainous regions. These glaciers flow down valleys and carve a deep U-shaped valleys into the land. Continental glaciers, also known as ice sheaths, cover large areas of land. The biggest examples are found in Antarctica and Greenland, with Antarctica holding the largest glacier system on Earth. So, where are glaciers usually found? Glaciers are mainly located near the polar regions and high altitude mountains. They exist in places like Alaska, the Himalayas, the Alps, and the Andes. Even regions near the equator can have glaciers if the mountains are high enough. Why are glaciers so important? Well, glaciers store nearly 70% of the world's fresh water. When glaciers melt, they feed rivers and lakes that provide water for drinking, farming, and electricity. Many communities depend on glacier meltwater, especially during dry seasons. Glaciers are also powerful land shapers. As they move, glaciers scrape and grind rock beneath them, carving valleys, fjords, and lakes. Many famous landscapes around the world were shaped by glaciers during the last ice age. However, glaciers are changing. Because of the rising global temperatures, many glaciers are melting faster than they can reform. This melting contributes to sea level rise and affects ecosystems and water supplies. Scientists study glaciers to better understand climate change and Earth's future. In summary, glaciers may move slowly, but their impact is massive. They shape the land, support life, and help us understand our planet's past and present. Deserts. A desert is not defined by heat, but by how little rainfall it receives. In fact, a region is considered a desert if it gets less than 10 inches of rain per year. Because of this lack of water, deserts have very dry conditions, limited plant life, and animals especially adapt to survive with very little moisture. So, how do deserts form? One major reason is global air circulation. Warm air rises near the equator and releases its moisture as rain. When this air moves towards the other parts of the world, it cools and shrinks, creating dry conditions. Many of the world's largest deserts, like the Sahara, are found in these dry zones. Deserts can also be from behind mountain ranges. Mountains block moist air, causing rain to fall on one side while the other side stays dry. This is called a rain shadow effect. Many people imagine deserts as endless seas of sand, but not all deserts are sandy. While sand dunes are common, especially in places like the Sahara, much of the desert surface is actually made up of rock, gravel, or hardened soil. Sand forms when rocks slowly break down over millions of years due to wind, temperature change, and erosion. Strong desert winds then move the sand and pile it into dunes. Deserts can be hot or cold. Hot deserts such as the Sahara or the Arabian Desert experience temperatures, heat at daytime and much cooler at nighttime. Cold deserts like the Antarctica or the Gobi Desert can have freezing temperatures and even snowfall, but they still receive very little rainfall. Despite their harsh conditions, deserts are full of life. Plants like cacti and shrubs have deep roots or thick skins to store water. Animals such as camels, lizards, snakes, and foxes are adapted to conserve moisture and avoid the heat. Many desert animals are nocturnal, meaning they come out at night when temperatures are cooler. Some of the most famous deserts include the Sahara, the largest and hottest desert in the world, the Arabian Desert, and the Gobi Desert. Surprisingly, Antarctica is actually the largest desert overall because it receives so little rainfall. Deserts are important to Earth's climate system. They influence weather patterns, store minerals, and are shaped by powerful natural forces like wind, erosion. While deserts may seem empty at first glance, they are dynamic environments that tell us an incredible story about Earth's climate, geography, and the resilience of life.
Biosphere, the ultimate life support system of our planet. It's where everything alive exists, from the deepest parts of the ocean to the highest mountains. But how does this actually work? What's inside it? Why is it so important? Let's break it all down. So what is the biosphere? The biosphere is the sum of all living things on Earth. Every plant, animal, and every microscopic organism, even humans, are a part of it. But there's more than just life itself. The biosphere also includes the environments that support life, such as land, forests, grasslands, desert, mountains, and even underground ecosystems like waters, ocean, lakes, and rivers, and tiny water droplets. And the atmosphere that provides oxygen protects us from the sun's radiation and helps control the Earth's climate. Basically, the biosphere is the thin layer of Earth where life can survive. It's a gigantic, self-sustaining machine, constantly recycling air, water, and nutrients to keep everything alive. Where was the biosphere found? Even though Earth is over 7,900 miles wide, the biosphere exists in just a thin shell wrapped around the planet. This is where the conditions for life are just right. The biosphere stretches across the atmosphere, the air we breathe, where birds fly and clouds form. The lithosphere, the solid land beneath us, including soil, rocks, and underground habitats. The hydrosphere, oceans, lakes, rivers, where marine life thrives. Most life is concentrated from a few kilometers underground to about 10 kilometers above the surface. Beyond that, conditions become too extreme, either too cold or too dry, or with too little oxygen for most organisms to survive. But life is surprisingly tough. Some microbes called extreme melophinos can live in places we'd never expect, like the deep sea, hypothermal vents, acidic hot springs, and even frozen glaciers. So while life on Earth mostly sticks to the biosphere, there are always exceptions. So how does the biosphere work? The biosphere is like a perfectly balanced system of life and energy. It follows three major cycles that keep everything running smoothly. The energy cycle. The sun is the biosphere's main power source. Plants use sunlight and photosynthesis to create food. Herbivores eat plants, carnivores eat herbivores, and the energy moves through the food chain. Eventually, the decomposers like fungi and bacteria break down the dead matter, returning the nutrients to the soil. And then we have the water cycle. The water evaporates from the oceans, lakes, and rivers to form clouds and then fall back as rain. This cycle moves the water through the biosphere, keeping plants, animals, and ecosystems hydrated. The nutrient cycle. Carbon, nitrogen, and other elements constantly move between the air, land, and water. Trees absorb carbon dioxide, animals release it when they breathe, and decomposers break down dead organisms and return the nutrients to the air. These cycles make life possible. If one of them stops working, the biosphere could collapse. That's why ecosystems are so interconnected. If you change one part, everything else can be affected. What lives in the biosphere? From tiny bacteria to giant blue whales, life in the biosphere is incredibly diverse. Scientists classify organisms into three main groups: producers, plants, and algae. They create their own food using sunlight. Consumers, animals, and humans. They eat plants or other animals to survive. Decomposers, fungi, and bacteria. They break down dead matter, recycling the nutrients back to the Earth's surface. Each organism plays a specific role. If we remove just one, the entire system could become unstable. For example, if pollinators affecting the entire food web. That's why biodiversity, the variety of life in the biosphere, is so important. The more species there are, the stronger and healthier ecosystems be. How do humans affect the biosphere? For billions of years, the biosphere has regulated itself, keeping Earth's climate and ecosystem stable. But just a few centuries, human activity has changed it drastically. How? Deforestation, cutting down forests, destroying habitats, releasing carbon into the atmosphere, and reduces oxygen and pollution. Plastics and chemical waste are everywhere, contaminating the water, air, and soil, harming ecosystems. Climate change. Greenhouse gas emissions heat up in the planet, causing rising sea levels, extreme weather, and shifting ecosystems. But this is not all bad news. Some people are also protecting the biosphere through conversion efforts, reforestation, and sustainable practices. If we take action, we can restore the Earth balance and ensure a healthy future for all life on Earth. So why is the biosphere important? Without the biosphere, we wouldn't exist. It provides oxygen to breathe, food to eat, and water to drink, and a stable climate to live in. The biosphere is self-sustaining, but only if we keep it that way. By understanding how it works, we can protect it and ensure life on Earth continuous for generations. Final thoughts. To sum it up, the biosphere is a complex interconnected web of life that depends on natural cycles to keep running. It's made of plants, animals, microorganisms, and humans all interacting with the environment. It's fragile yet real science. Ancient yet constantly changing. Every breath you take, every meal you eat, every drop of water you drink comes from the biosphere. Without it, Earth would be lifeless as Mars. That's why we need to respect it, protect it, and learn from it. Tornadoes are some of the most powerful and destructive forces of nature. They seem to come out of nowhere, leaving a trail of devastation behind them. How do these twisting columns of wind actually take shape? What conditions create them, and why do they form in some areas more often than others? But before we get started, if you're new to this channel, make sure to hit the like button, subscribe, and follow Science by PK for more fascinating science breakdowns just like this one. Let's dive right into it. Tornadoes form during thunderstorms, specifically a rare and powerful type of thunderstorm called a supercell. Supercells are massive thunderstorms with rotating updrafts of air, and they are the perfect breeding ground for tornadoes. So how does this rotation start? It all begins with wind shear, which occurs when winds at different altitudes move at different speeds or directions. Imagine the wind close to the ground moving slowly in one direction, while stronger winds high in the atmosphere blow faster in a different direction. This creates a rolling motion in the air, like an invisible horizontal cylinder spinning above the ground. Now, this horizontal spinning air doesn't just become a tornado just yet. The next critical ingredient is an updraft. This is when warm, moist air near the surface rises into the atmosphere. When that rising air tilts, the spinning horizontal winds start to turn into a vertical position. This forms a rotating column of air inside the storm. This is called a moist cyclone, and it's the heart of a supercell. But not all moist cyclones produce tornadoes. For a tornado to form, the conditions must be just right. The rotating air in the mesocyclone begins to stretch vertically, tightening like an ice skater pulling their arms during a spin. This is when a funnel cloud appears. If the funnel reaches the ground, it officially becomes a tornado. So why do tornadoes form in certain areas more often than others? A lot of it comes down to geography. In the United States, there's a region called Tornado Alley, which stretches from Texas to South Dakota. This area is a hotspot for tornadoes because it's where warm, moist air from the Gulf of Mexico meets cool, dry air from Canada and the Rocky Mountains. This clash of air masses creates the instability needed for tornado formation. But tornadoes aren't exclusive to Tornado Alley. They've been recorded on every continent except Antarctica. Countries like Bangladesh, South Africa, and even parts of Europe experience tornadoes, though they are less frequent than the US. So what makes tornadoes so destructive? It's their wind speeds. Tornadoes are ranked on the U-linked Fujita scale, or EF scale, which ranges from EF0 to EF5. EF0 tornadoes are the weakest, with winds around 65 to 85 miles per hour, still enough to cause damage at other ends of the spectrum. But EF5 tornadoes have wind speeds accelerating 200 miles per hour, capable of leveling entire neighborhoods. The most dangerous aspect of a tornado isn't just the wind, it's the debris it picks up. Pieces of buildings, trees, and even cars can become deadly projectiles, making tornadoes incredibly hazardous. So how is this possible for nature to create something so powerful and destructive? It's all about the perfect combination of ingredients: warm, moist air, cold, dry air, wind shears, and atmospheric instability. When all these elements come together, they create the perfect storm, literally. But here's something to think about. Scientists still don't fully understand why some supercells produce tornadoes and others don't. It's one of the biggest mysteries in meteorology. Tornadoes remain unpredictable despite advances in weather technology. However, tools like the Doppler radar and storm chasing research teams have significantly improved our ability to detect and warn people about tornadoes. Tornadoes are a reminder of nature's incredible power and complexity. They form through a delicate balance of forces, and when that balance is tipped just right, it creates one of the most awe-inspiring and terrifying phenomena on Earth. Blizzards. How do they form, why do they happen, and what makes them so dangerous? And what do you need to stay safe during one? We'll also talk about how snow and snow crystals form, as well as the power of these intense winter storms. Stick around for this chilly deep dive. Blizzard isn't just a regular snowstorm. It's a very specific and extreme weather event. For a snowstorm to officially be qualified as a blizzard, it needs to meet 3 key conditions. First, the winds must be saturated at 35 miles per hour or higher. Second, visibility has to be reduced to 1/4 of a mile or less due to the blowing of or falling of snow. Third, these conditions must be precise for at least 3 hours. It's not just the amount of snow falling that makes a blizzard dangerous, it's the combination of snow, wind, and visibility that turns an ordinary winter storm into a deadly blizzard. So how do blizzards form? Like many extreme weather events, blizzards need perfect combination of atmospheric ingredients. The first essential component is cold air. For snow to form, the air temperature must be at the surface, must be higher in the atmosphere, and must be at or below freezing negative 32 degrees. Without this freezing air, the moisture in the atmosphere would simply fall as rain instead of snow. The second component is moisture. This often comes from large bodies of water, such as oceans, lakes, which provide the water vapor needed for the snow formation. Lastly, strong winds are the final ingredient, which blow the snow around and create the binding, swirling conditions that make blizzards so dangerous. Blizzards are often caused by low pressure systems that bring together cold air from the north and warm air from the south. When these two air masses meet, the warm air is forced to rise over the cold air. As the warm air rises, it cools, and the moisture it contains condenses into clouds and eventually snow. The strong winds that accompanied blizzards come from the differences in pressure between two air masses. The bigger the difference in pressure, the stronger the winds. Now let's take a closer look at the snow itself. How does snow form? It all begins with water vapor in the atmosphere. When this water vapor freezes, it forms tiny ice crystals. These ice crystals stick together as they collide, creating snowflakes. Each snowflake is unique because its shape is determined by the temperature and humidity of the clouds it forms in. The intricate patterns we see in snowflakes are the result of tiny changes in the environment as they grow. Once these snowflakes become heavy enough, they fall to the ground. If the air near the surface is freezing, the snowflakes remain intact and create a soft, powdery snow we associate with winter storms. Blizzards are dangerous for several reasons. Whiteout conditions caused by blowing snow that reduce visibility, making travel extremely hazardous. It's easy to lose your sense of direction in a blizzard, even if you're just a few feet away from the shelter. The cold temperatures can also cause frostbite and hypothermia if you're exposed for too long. Additionally, the weight of heavy snow can damage trees, power lines, and buildings, leading to widespread power outages and infrastructure damage. Not all snowstorms are blizzards, but even less severe snowstorms can be dangerous. There's also something called a ground blizzard, which happens when a strong wind blows loose snow from the ground, creating whiteout conditions. Even if there was no new snow falling, ground blizzards can be just as deadly as traditional blizzards because they still create dangerously visibility and wind conditions. While blizzards aren't categorized as an official scale like hurricanes or tornadoes, meteorologists often describe them based on their intensity. Severe blizzards may have wind speeds accelerating for over 50 miles per hour. Extremely low visibility and temperatures can drop below freezing. Some historic blizzards, such as the blizzard of 1888 in the United States, are remembered for massive destruction and the loss of life. The storm dumped over 50 inches of snow in some areas and caused more than 400 deaths, highlighting just how deadly these events can be. If you find yourself caught in a blizzard, prepare Preparation and safety are a key. The most important rule is to stay indoors if possible. If you must travel, make sure your vehicle is equipped with emergency supplies, including blankets, food, water, and a flashlight. If you're on foot and unable to reach a shelter, find a protected area to shield yourself from the wind. Cover exposed skin to prevent frostbite and conserve your energy. Over restrictions such as trying to shovel heavy snow for extended periods can be dangerous in freezing conditions. Blizzards are an incredible display for nature's power and the form of unique snowflakes into massive storms that can blanket entire regions. There's much to learn and appreciate about these winter phenomenons. Understanding the science behind blizzard not only helps us stay safe, but also gives us a greater appreciation for the complex forces that work in our atmosphere. Have you ever wondered how tsunamis form? These massive towering waves can travel across entire oceans, leaving destruction in their wake. But what exactly causes a tsunami? Why do they happen? And how do they grow so powerful? Today on Science by PK, we'll dive into the fascinating and terrifying science of tsunamis. Stick around to the end and make sure to like, subscribe, hit the notification bell before we continue. First, let's get one thing clear. A tsunami is not just a regular wave. Regular waves are caused by wind moving across the surface of an ocean. A tsunami, however, is a wave caused by the sudden displacement of massive amounts of water, and it involves the entire depth of the ocean from surface to the seafloor. This is why tsunamis are so powerful. They move enormous volumes of water at once. In fact, a tsunami can travel at speeds up to 500 miles per hour in the open ocean. That's as fast as a commercial plane. So how do tsunamis form? The most common cause is underwater earthquake. When tectonic plates in the Earth's crust shift or collide, the seafloor can either rise or fall abrupt. This movement displaces an immense amount of water, which ripples outwards in all directions. Imagine dropping a rock into a still pond. The ripples spread out evenly, but on the ocean scale, these ripples are as massive and incredibly energetic. But earthquakes aren't the only triggers for tsunamis. Underwater volcanic eruptions can also displace water when a volcano erupts. It can cause sudden explosion or collapse, pushing water away from the eruption site. Similarly, when water landslides caused by collapsing slopes on the ocean floor can shift water, suddenly generating a tsunami. Even meteorite impacts tsunamis, although it's a rare case, but they can also create tsunamis if the impact occurs in an ocean. Essentially, anything that causes a rapid displacement of water can trigger a tsunami. Once a tsunami is triggered, the way it moves across the ocean is fascinating. In the deep ocean, tsunamis are barely noticeable. They might be only a few feet high, and their long wavelengths make them seem like gentle swells. But as the tsunami approaches a shallow coast water, it slows down, and when the wave slows, all that energy is compressed, causing the wave to grow dramatically in height. This is why tsunamis near the shore can reach towering heights of 30 feet. Or even more during extreme events. These waves don't just hit once, they come in a series called a wave train, with each wave potentially being larger than the one before. Most tsunamis occur in the Pacific Ocean, especially along the Ring of Fire. This region is a hotbed of tectonic activity, where massive plates of the Earth's crust are constantly moving, colliding, and shifting. Countries like Japan, Indonesia, and Chile are particularly vulnerable to tsunamis because they sit near these active plate boundaries. However, tsunamis aren't limited to the Pacific. The Indian Ocean and even the Atlantic Ocean have seen their share of devastating tsunamis, such as the 2004 Indian tsunami, which claimed over 230,000 lives across 14 countries. The impact of the tsunami is often catastrophic. When a tsunami hits hard, it brings with it an immense force and energy capable of flattening buildings, uprooting trees, and washing away entire communities. But it's not just the towering waves that cause destruction. Tsunamis often create storm surges, where seawater floods inland, and heavy flooding can remain long after the waves recede. This flooding can destroy crops, contaminate freshwater supplies, and leave behind layers of mud and debris, making it even more difficult for recovery. One of the deadliest tsunamis in history was the 2004 Indian Ocean tsunami, which was triggered by a massive 9.1 magnitude earthquake off the coast of Indonesia. The waves traveled across the Indian Ocean, reaching as far as East Africa. Entire villages were wiped out and millions were left homeless. The sheer scale of the destruction showed how devastating tsunamis can be. Now let's talk about how we can detect and predict tsunamis. Advances in technology have made it possible to track tsunamis and issue warnings before they reach land. Seismic monitoring stations detect underwater earthquakes, while ocean buoys measure changes in water levels. When an earthquake capable of causing a tsunami is detected, warning systems can alert nearby regions. However, the challenging part is the time. Since tsunamis travel so quickly, people in affected areas only have minutes or hours to evacuate. This is why education and preparedness are so important in tsunami-prone regions. So what should you do if you ever find yourself near a coast and a tsunami warning is issued? First, don't wait to see the wave. Move to higher ground immediately or as far inland as possible. If you notice the ocean suddenly receding far from the shore, it's a major warning sign a tsunami wave could be on its way. Pay attention to the alerts and stay away from the coast until the authorities say it's safe to return. Tsunamis are a reminder of how powerful and unpredictable nature can be. They focus on the powers nature has, but they leave impacts that last for generations. Understanding the science behind tsunamis helps us prepare these disasters and save lives. If you found this breakdown of tsunamis fascinating, don't forget to like this video, subscribe to Science by PK, and hit the notification bell so you never miss out on a new episode. Let us know in the comments on what natural phenomenon you would like for us to explore next. Thanks for watching and stay curious.